Hello guys, you're welcome back to my channel Fun with Physics. In this lesson we are going to consider electric circuit, and at the end of the lesson you'll be able to describe how to draw circuit component in a simple circuit diagram, and you'll be able to describe how to test if an object will conduct electricity or not. That is, if the object is a conductor or an insulator. Now, as a starter, can you make a list of all the items you can find in the picture there that use electricity? A quick list. Okay, now that you've made a list of few items that uses electricity, we can proceed. Now, what's the difference between static and current electricity? It's a common word, static and current. Of course, the word static means not moving, and current means mobile, it's moving. So static electricity describes the situation where electric charge remains stationary, they are not moving, and it's best in insulators. While current electricity describes a situation where charge move from one place to another, and this is best with conductors. That is to say that conductors will allow the free flow of charge, whereas insulators will not. Okay, now circuit components. By circuit components, we mean all the items you can actually find in a circuit: the switch, the cell, wire, and all whatnot. Everything you can find in a circuit are the circuit components. Okay, now in a simple circuit component, you can of course find a lamp, a switch, and a battery. These are the basic. Okay, but in a complicated circuit diagram, you can find more than that. Now, how can you light the bulb using only the provided circuit components? You're provided with a wire, a battery, a bulb. So how can you light the bulb when you must not cut the wire, if you are not allowed to cut the wire? Guys, I want you to think about it and comment on the comment section, okay? What you feel, or how you feel, or how you think you can light the bulb without cutting the wire. Now, let's see how many of these electronic circuit components you know. Resistor, capacitor, diode, switch, LED, that's a light emitting diode, the battery, relay, loudspeaker, fuse, integrated circuit, transformer, and so on. How many did you know, and or how many have you ever seen before? Now, if you've been to places where mobile phones or your TV set are fixed or are repaired, you get to see some of these items. Okay, if you have a computer and you're fortunate to see the motherboard of the computer, you see some of these items. All right, now circuit components could be difficult to draw. Okay, so in a situation where we need to draw bulb, wire, motor in a single circuit, now it will be complicated for you to start drawing all of these items. So for that reason, we use symbols to represent the components. Okay, now we use this symbol, a straight line, to represent a wire, and we use two lines, two parallel lines, one short and one longer, to represent a cell. Okay, for battery we use more than one cell. For a lamp, we use a circle and a cross inside. An open switch, closed switch, buzzer, and motor. These are some of the symbols. Okay, so the few symbols we use. We have more symbols that we use for each of the circuit components that you can think of or that you know. Okay, now common components, the common ones, the ones we see in our basic circuit diagrams. The wire, for instance, is one common one. And when it's connected, you get to see a cross like this, or a cross with a point showing the point of connection. Okay, but when it's not, when it's connected, you get to see a T connection, or this a T with a point where it shows connection. But when it's not, you get to see a cross showing that it's not connected, or this. All right. Now a switch is basically what is used to control the charge flowing through the circuit. Okay, you can use it to open or to close, that is to on or off the circuit. By opening we mean on. By opening we mean off. By closing we mean to on it. Okay, so when it's open here, this is how we get to draw it. It means it's off. It's open. When it's open, it means charge cannot flow through, but when it's closed, it means it's bridged. Charge can actually pass through it. Okay, so this is on when it's closed. Now for a cell, like I said, we use this symbol, and it is important that you know that cell is the primary source of the energy in a simple circuit. Okay, that supplies the required voltage needed for the charge, or the potential difference needed for the charge to flow. Okay, now each cell has a certain amount of voltage it can supply, or energy it can supply for a single charge to carry. Okay, for instance, a 5-volt cell can supply 5 joule of energy for a single charge to carry through the circuit, and so on. Now a battery, of course, is made up of different cells combined together in series. Okay, that is one beside the other one, or end-to-end kind of arrangement. Now we have a 12-volt car battery here. It means it contains about 6 2-volt cells inside. Are we good? Now the lamp is what we can see in the picture here, and the common one is a filament lamp that has some fine wires that are right inside here. Now when these wires are heated up, they glow and then give out the required light energy that we'll use to see and do other stuff. So the symbol is this. Now let's have a quick look at this, or what we have here. Now for switch, here it's open and here it's closed. For a bulb, we have it here. For a variable resistor, that's a resistor that you can actually alter, you have this symbol with an arrow to show that you can actually alter it. For a fixed resistor, this is it. A fixed resistor is a resistor that is specified. Okay, for instance, maybe 5 ohm resistor, and so on. Anyway, as we proceed to other units of the lesson, you get to know better. This is an ammeter, which is used to measure current, and a voltmeter used to measure the voltage or the energy or the potential difference, as you may call it. Okay, now let's have a quick review with a quick quiz, okay, to see how much you know. Now, which symbol do you think represent battery from all of these symbols? This, of course, because it has more than one cell. Now, which symbol represent a closed switch? Of course, this, because that's the open switch, the opposite. Which symbol represents a voltmeter? The one with a circle and a V. Which symbol represents a variable resistor? This, the rectangle with an arrow showing that you can alter it. Now, which symbol represents an open switch? Of course, this. Which symbol represents a fixed resistor? This is it. And which symbol represents a filament lamp? This is it, of course. And then lastly, which symbol represents the ammeter? Base, of course. So for the voltmeter and the ammeter, you see the letter A to show that it's an ammeter, and the letter V here to show it's a voltmeter. Okay? Alright, now the circuit diagram. How do we draw it? How do we sketch it? It's simple. All you need to do is to follow what you have here. Now if you look at this, you have two cells, which is a battery. We have the positive side, a negative, positive, negative. That means you need to draw the positive, negative, positive, negative. The positive is always the longer one, the longer line. The positive, the negative is a short one. Notice that positive is before negative here. Okay? Then the wire connecting a lamp and same wire connecting another lamp. So take it the same way. Connecting a lamp, connecting the second lamp, and then connected to an open switch. Wire connected to an open switch back to the negative terminal of the cell. Okay, so it's a simple thing, simple arrangement that you can actually sketch. Now, can you try this? Try to draw a circuit diagram for this circuit. You need to draw a circuit with one cell and one bulb. Now, if your drawing is like this, then you are correct. Okay, now let's try this one. Check this one out and try it. In this case, you need to draw a circuit with one cell and two bulbs. Notice that the switch is between the two bulbs. Okay, it's one cell, and the positive side of the cell is on the left hand side. Now if your drawing look like this, then you are correct. Okay, good one. Now conductors and insulator. We already know that conductors allow the flow of charge and insulator don't. But if we want to find out or verify given different items, we can easily do that by having a connecting wire connected to a cell and a lamp to serve as an indicator that will tell us when current is flowing or not. In the absence of this, you can also use an ammeter to tell you if current is flowing or not. Okay, then you have an open end here where you have some crocodile clips. Okay, so you take the item you need to test and put in between this end and hold them firmly with the crocodile clip. If this light shows, it means the object is a conductor. Now you can also check if it's a very good conductor or not, depending on the brightness of the lamp here. If it's very bright, it means a very good conductor, but if it's not, it means it's not a good conductor. Okay, so here are a few lists of items that can be tested. You have a metal spoon, paper, coin, aluminium, foil, wood, plastic spoon, rubber, graphite, so on. Which of these items are conductors? So basically, all metals are conductors. So you can cross out metals here. We have this metal spoon, aluminium, a coin, and that's it. Aluminium foil, that's it. Okay, and then for a non-metal, we have graphite. It's a lot of carbon that is a conductor, so you can also cross it out. It's a conductor. Okay, all right, now let's take a quick one here to see how far we can be able to remember a good circuit diagram. How far we can be able to tell if a circuit diagram is okay or not. So in which circuit diagram here shows a complete circuit? complete with all the components. I think this, yes, of course. We have all the components and it's closed. So it's a complete. Notice that you need a battery or a cell to have a complete circuit. Here you have an ammeter, but it's open, so it's not complete. Which circuit contains a variable resistor? Of course this. This one has a fixed resistor, but this has a variable resistor because of the arrow. The arrow shows that the resistor can be altered, can be changed. Which circuit contains a lit bulb? Now you may be tempted to take this, but this is what we call short circuiting. It's like providing an alternative path for charge to flow. Okay? So this one will contain a lit bulb, but this one the bulb will not light because that's an alternative path for the charge to flow. Which circuit contains an open switch? Of course this. This is no switch at all. Which circuit contains a battery? Of course this. This one has a cell, but this has more than one cell. That's two cells, which is a battery. Which circuit contains a short circuit? This is it. Okay guys, well done guys. Please comment whatever question you have, comment on the comment section and I'll get back to you definitely. Okay, and don't forget to subscribe to my channel for more PowerPoint lessons like this. Have a nice day.